To start this lesson video, let me first introduce to you this person, Carl Friedrich Gauss. He is a German mathematician who proved the fundamental theorem of algebra, wherein every polynomial function f of x is equal to 0 of degree n has exactly n zeros. So it simply says that whatever the degree of a polynomial expression is, that would also be the number of roots or zeros. So these two terms are interchangeable. They have the same meaning in math. Say for example, here, since the degree of this polynomial function is 2, then it has 2 roots or zeros. And today I am going to discuss and show you how to get the factors of polynomials. We will be using the trial and error method in getting the factors of polynomial expression. So trial and error by means of synthetic division. So to do that, you will assign possible roots to the given polynomial expression. Kayo yung mag-a-assign kung ano-ano ba yung posibleng roots ng polynomial expression na given. But what will be the basis in assigning the possible roots? Ano ba yung magiging basihan sa pag-assign nyo ng roots? It's the constant term of that polynomial expression. We have to get all the factors of the constant term. So here, the factors are 1 and 2 only. But always include both the negative and positive integers. So the possible roots here are positive negative 1 and positive negative 2. Then we use each factor in performing the synthetic division. We can say that that number is a root to a polynomial expression if we get 0 as the remainder. Masasabi natin na ang number na iyan ay root sa given na polynomial expression kung ang makukuha nating remainder pag ginamitan natin ng synthetic division ay 0. Okay, so let's do it. So let us try to get the factors of this given polynomial expression. Consider the constant term. The constant term here is 2. What are the factors of 2? The factors are 1 and 2. But again, consider both the positive and negative integers or numbers. So we have positive negative 1 and positive negative 2 as possible roots. Since the degree of this polynomial expression is 3, then there will be 3 roots or zeros for this polynomial expression. And since we have positive negative 1 and positive negative 2, ibig sabihin, tatlo dito yung roots nitong polynomial expression na ito. So let us perform the synthetic division using these possible roots. So let us take all the numerical coefficients of the given polynomial expression. Make sure that the terms of the given polynomial expression are complete. Okay? So in this case, kompleto naman yung lahat ng terms. Pababa naman yung exponents nila. So we have, for the first numerical coefficient 1, we have negative 2, second numerical coefficient. We have negative 1 for the third numerical coefficient. And lastly, we have 2. Then, we draw lines like this. Then let's have positive 1 first. Saan galing si positive 1? Dito sa possible roots. So dito muna tayo sa positive 1. So perform synthetic division. Bring down 1. Multiply 1 by 1, it's 1. Perform addition, we get negative 1 here. 1 times negative 1 is negative 1. Perform addition, we get negative 2. 1 times negative 2 is negative 2. Then perform addition, we get 0. Since the remainder here is 0, then we can say that 1 is one of the roots of this polynomial expression. So may hinahanap pa tayo, dalawa pa. So we have 1 as one of the roots. So let us still find the other two roots. Let's have negative 1. So bring down 1, multiply these two values, negative 1. Perform addition, we get negative 3. Multiplication, negative 1 times negative 3, it's positive 3. Perform addition, we get positive 2. Then we multiply these two values, we get negative 2. Perform addition, we get 0. So again, since the remainder here is 0, we can say that negative 1 is one of the roots of this polynomial expression. So meron na lang tayong isang hinahanap. Let's have positive 2. So bring down 1, multiply 2 by 1, we get 2. Perform addition, we get 0. 2 times 0 is 0. Perform addition, we get negative 1. Multiply 2 by negative 1, we get negative 2. Then perform addition, we get 0. So since the remainder here is 0, we can say that 2 is one of the roots of this polynomial expression. So kumpleto na ba yung roots? Kumpleto na ba yung bilang ng roots na hinahanap natin? We have 3 here. Positive 1, negative 1, and positive 2. So kailangan pa ba natin, class, mag-proceed sa negative 2? No need na kasi nga kumpleto na yung tatlong roots. Just for us to have the feeling of completion, let's have negative 2. So let's check. Bring down 1, negative 2, negative 4, multiply, positive 8, add 7, multiply, negative 14, add negative 12. So the remainder here is negative 12. So we can say that negative 2 is not one of the roots of the given polynomial expression. So as simple as that, class. That's how we get the roots of a given polynomial expression. But how can we now write the factors? We have already the roots. Ang topic natin ay factoring polynomials. Bakit roots yung hinahanap natin? Because using these roots, we can write the factors of polynomials. Since there are 3 roots, we will write also 3 pairs of parentheses. So we have x. Then we have the first root. We have positive 1. But get its opposite sign, it's negative 1. So we write here minus 1. Okay? Take note of that. If the root is positive, then the operation inside the parenthesis is negative. On the other hand, if the symbol of the root is negative, then you have to use plus inside the parenthesis. Okay? For the next factor, we have x. Get the opposite sign of negative 1. It's positive, so plus 1. Then last factor would be x minus 2. So these are now the factors of this polynomial expression. As simple as that. Let's have another example. Let's try to get the factors of this. So what is the constant term? It's 18. What are the possible roots? So what are the factors of 18? We have 18 times 1, 9 times 2, and lastly, we have 6 times 3. So therefore, the possible roots are positive negative 1, positive negative 2, positive negative 3, positive negative 6, positive negative 9, and positive negative 18. In this case, class, ang dami yung possible roots. So, posibleng madami din kayong gawing trial and error method using the synthetic division. But that's okay. Ang dali lang naman ng synthetic division. Okay, the degree of this polynomial expression is 4. Therefore, we are looking for 4 roots of this polynomial expression. Now, what are the roots? Let's perform the synthetic division method. Kompleto naman yung terms ng given polynomial expression. So, the numerical coefficients are 1, negative 1, negative 11, 9, and 18. Let's try positive 1. Bring down 1, multiply, we get positive 1, add, we get 0, multiply, 0, add, we get negative 11, multiply, we get negative 11, add, we get negative 2, multiply, 1 by negative 2, we get negative 2. Then add, we get 16. So since the remainder here is 16, then we can say that 1 is not a root to this given polynomial expression. Let's try negative 1. Bring down 1, multiply, we get negative 1. Add, we get negative 2. Multiply these two values, positive 2. Add, we get negative 9. Negative 1 times negative 9 is positive 9. Then we add this, we get 18. Negative 1 times 18 is negative 18. Add these two values, we get 0 as the remainder. So since the remainder here is 0, we can say that negative 1 is one of the solutions of this polynomial expression. So we put negative 1 here. So meron na lang tayong hinahanap na tatlo. Now let's try positive 2. Bring down 1. Multiply, we get 2. Add, we get positive 1, multiply it by 2, we get 2. Add these two values, we get negative 9. We multiply 2 by negative 9, we get negative 18. Then we add these two values, we get negative 9. We multiply these two values, 2 and negative 9, we get negative 18, and then we get 0 as the remainder. Nakakuha na tayo ng dalawa. We have negative 1 and 2. So, two more roots. Same procedure, we'll get positive 3 and negative 3. So, these are now the roots of this polynomial expression. So, since the degree here is 4, we'll write also 4 parentheses. So we write x as the first terms of these expressions. Then we have -1 as the first root. So get its opposite sign, we have +1. Next, we have -2. We have -3 and +3. So these are now the factors of this polynomial expression. So that's it. Let's have the last example for this lesson video. So in this case, as you can notice, the numerical coefficient of the first term is not 1. Kumpara dun sa dalawang naunang examples, parehas 1 yung numerical coefficient ng first term. But this time, the numerical coefficient is 3. So you also have to consider this in indicating the possible roots of these polynomial expressions. The constant term here is 12. The numerical coefficient of the first term, which we call the leading coefficient, we call this the leading coefficient. Okay? It's 3. Now, what are the possible roots? Considering the constant term and the leading coefficients, what are the factors of 12? We have 12 times 1, 6 times 2, and 4 times 3. How about 3? We have 3 times 1 only. So the possible roots are, iisa-isahin natin to, factors ni 12. So lahat yan kasali. We have positive -1, positive -2, positive -3, positive -4, positive -6, and positive -12. We will also consider the factors of the leading coefficient. We have positive -1 and positive -3. But, as you can see here, included na yung positive -1 and positive -3 dito sa first set of possible roots natin. So, we will not include this anymore. Pero may kulang pa dito sa possible roots natin. We still have to divide each of the factors of the constant term to each of the factors of the leading coefficient. So, let's try. 1 divided by 1 is 1. Pero included na yung positive -1 sa first set of possible roots natin. So, there's no need for you to write it down again. So, 1 divided by 3 is 1/3. So, another possible roots, we have positive -1/3. Okay, nasa 1. Next, we have 2. 2 divided by 1 is 2. Included na yung 2. So, skip na yan. Next, 2 divided by 3 is 2/3. So, lagdagan natin to ng positive -2/3. Next, 3. 3 divided by 1 is 3 included na. So, wag nang ulitin. 3 divided by 3 is 1 included na rin. Next, 4. 4 divided by 1 is 4. Included na yung 4. Skip na yan. 4 divided by 3 is 4/3. So, dagdagan natin ng positive -4/3 dito. 6. 6 divided by 1 is 6 included na. 6 divided by 3 is 2 included na rin. Next, 12. 12 divided by 1 included na. 12 divided by 3, 4 included na rin. So, these are now the possible roots. Again, if the numerical coefficient of the leading term is not equal to 1, you will also consider the leading coefficient or the numerical coefficient of the leading term in writing the possible roots of that polynomial expression. Paano nga ulit? Inisa-isa natin yung factors ng constant term. Ito. Then automatic, kasali sila sa possible roots. Lalagyan lang natin ng positive negative signs. Then automatic din, kasali yung factors ng leading coefficient natin. Pero since kasali na yung 1 and 2 sa first set of possible roots natin, hindi na natin in-include yan. Ang sunod na gagawin natin ay we divide each of the factors of the constant term by each of the factors of the leading term. Inisa-isa nating i-divide yung factors ng constant term sa factors ng leading coefficient. And isasali natin yun sa possible roots. Okay? So, ang dami, class. Mabuti sana kung mababa lang yung constant term. Pero in this case kasi, class, medyo madami ng factors yung constant term natin. Kaya madami din yung possible roots. But since the degree of this polynomial expression is 3, there will be 3 roots for this polynomial expression. So, kompleto naman yung terms ng polynomial expression. So, we have 3, 2, negative 37, and 12. So, isa-isahin natin to, class. Yun lang yung medyo hassle na part dito. Yung paghanap ng roots. Considering the number of possible roots. May karamihan din to. Let's try 1. So, bring down 3, multiply, add, multiply, add, negative 35, negative 32, then multiply, we get negative 32. We add these two numbers, two values, we get negative 20. So, since the remainder is not equal to 0, therefore, 1 is not the root of the given polynomial expression. Let's try positive 3. So, bring down 3, multiply 3 by 3, we get 9, add 11, multiply 33, add, we get negative 4, multiply 3 by negative 4, we get negative 12, and we get 0 as the remainder. Therefore, positive 3 is one of the roots of this polynomial expression. So, meron pang dalawa. Let's try negative 4. Bring down 3, multiply negative 4 by 3, we get negative 12, perform addition, negative 10, multiply, positive 40, add, positive 3, then multiply, we get negative 12, then we get 0. So, may isa na tayo na idagdag ulit. Negative 4. Isa na lang. To make it short, 1/3 is one of the roots of this polynomial expression. So, let's do it. Bring down 3. Multiply 1/3 by 3, we get positive 1. Perform addition, we get 3. 1/3 times 3 is 1. Negative 37 plus 1 is negative 36. Multiply it by 1/3, we get negative 12. And we get 0 as the remainder. So, kompleto na yung roots natin. We have 3, negative 4, and 1/3. What are now the factors of this polynomial expression? We have x minus 3. Again, we get the opposite sign of the roots. That's why we have here minus 3. Next, x plus 4. And how about this? 1/3. The denominator, class, will be placed in the first term of this expression. So, mapupunta siya sa first term. Instead of writing x, we write 3x. Then, we use negative kasi nga opposite sign yung kukunin natin. Then, yung numerator mapupunta dito sa second term. Okay? Let's say we have negative 2/3. Paano natin ilalagay dito? As factor. So, we have 3x, yung denominator, ito yun. Then, what's the opposite sign of negative? It's positive. Yung numerator mapupunta sa second term. Okay? So, these are now the factors of this polynomial expression. And that's it for this lesson video. I hope it's clear to you. Thank you so much for listening.